While we've defined a sample in a previous video, we haven't talked about how to get one. So here we'll talk about a few different ways to get samples. We'll look at 4 in depth and then talk about a few more very briefly. The first one we're going to talk about is a random sample. In a random sample, all the members of the population have an equal chance of being selected. Usually the way this is done is every member of the population will be assigned a number, and then we have a computer generate a sequence of random numbers, and then we'll just pick those particular people. These are the most ideal in statistical studies, but they can also be some of the most difficult to obtain sometimes. So while they are ideal, they're not always practical. So let's look at a few others. The next one we'll look at is called a systematic sample. And in a systematic sample, we pick some number, which we'll call k, and we just select every kth member of the population. The number k can be any number depending on what we need. Maybe we want to select every 5th member, or maybe we want to select every 200th member. It really depends on what we're doing. You can occasionally see systematic samples when we're doing security checks and random security checks. They'll pick a number and look at every 10th person, or whatever the number happens to be. In addition, it's very common for quality control. When we have an assembly line that is creating something, we'll pull every 1,000th or every 10,000th item off the line to test it for defects. And so we see this a lot in quality control. The next one we'll look at is called a stratified sample. Stratified samples can be a little bit more confusing than our last 2 examples. So the first thing we do is break the population up based on some kind of characteristic. So our first step is to divide the population. Once we've done this, we're going to select people from each group, and we have to make sure we include all of our groups. So essentially, once we divide the population, we're going to pick some people from every group. And while I say people, what we really mean here is individuals. Depending on whatever we're doing our subject on, we're just going to break our population and select some individuals from every group. And it's important that we only take some people, but we do select from every group. A lot of times we see this broken up by age. We want to make sure different age groups are included. Or gender, we want to make sure we have a nice representation of men and women. It could be political affiliation, religion, or all kinds of other things. But essentially, we want to make sure we have representation from every single group. Next, we have a cluster sample, and a cluster sample is going to be very similar to a stratified sample. Once again, we start by breaking the population into groups. Once we've done that, we're going to select one or more of these groups and talk to everyone in the group. In a stratified sample, we broke the population up into groups, and we made sure to pick some people from every group. Here we're going to select every person from some groups. So we're not going to make sure all groups are included, but we are going to make sure everyone in that group is included. An example of this is if we wanted to see how patients were satisfied with their hospital experience in the city of New York. If we tried to do one of our other methods, we would be driving all around New York to various hospitals, tracking down people in various rooms, and it would be very time-consuming. However, if we do a cluster sample, we could just pick 1 or 2 hospitals and speak to all of the patients in those hospitals rather than driving all around town. So that would be more ideal in this situation. While random, systematic, stratified, and cluster samples are the most common ones, there are a few others that we'll discuss now. The first is called convenience sampling. And convenience sampling is exactly what it sounds like. We're going to use subjects who are convenient. This is usually not a representative sample. If we're dealing with people, convenience sampling is usually our friends or our family or people that we deal with every day. So it's usually not the best sample, but it can be done, just basically whoever's nearby. The next is a volunteer or self-selected sample. These are where respondents decide if they want to be included, and it's usually people who feel very passionate one way or the other. Mainly because they have to decide that they want to be included, and usually you don't want to be included unless you are very strongly for or against. So they're also not ideal because you don't usually get the middle of the road people. There's also a method called multi-stage sampling, and this is essentially where we're going to use several different methods to get smaller and smaller samples. And this is going to be very common in drug trials. Usually the first round is going to be volunteer, self-selected. People decide that they want to be included in this. And then we use these other methods to get smaller and smaller and smaller groups until we have our group that we actually do want to drug test on. The last thing I want to talk about here is some error. There are going to be two types of error when we're dealing with statistics. The first is called sampling error. And sampling error just tells us essentially that no sample is perfect. No matter what sampling method you use, there is going to be some sampling error, and this is just the difference in what happened between your sample and what the results for the actual population are. Depending on which method you use, your sampling error could be much smaller or much larger, but there is always some sampling error. No sample can be perfect unless we were to actually complete a full census and talk to everyone in the population. There's also error called nonsampling error, and this is any error not directly the result of a sample. It could be data that was obtained erroneously or human error. We're typing in thousands of numbers into a program. Maybe we made a mistake in typing a data point in, or maybe our calculations were off somehow. So this is any kind of data in error that's not a direct result from the sample.